Alpha Houston on space to ground 1 for Don. We're ready for your downlink.
Okay, I'm going to hit play.
I'm Don Pettit. I was fortunate enough to be science officer on Expedition 6 to the International Space Station. And during this expedition, we had several kinds of science that we did. We did programmatic science, which is well-planned and well-thought-out science, comes up from the ground and is orchestrated from the ground. And then we have science of opportunity. And this is science that is done at the discretion of the scientists on board space station. And this is kind of the discovery science. And during our mission, we called our science of opportunity Saturday morning science. Now we're going to look again at spherical geometry, but this time we're going to make a big sphere. We're going to make a sphere that ended up being about the size of my head. And the only reason I came up with was making this is that the ratio of surface tension forces to inertial forces is going to decrease as the sphere gets larger. And I thought something neat might happen here if we make a big sphere of water as opposed to just having smallish spheres of water. So here we're in the process of making one of these big spheres.
I'm just adding water to it slowly because it's real easy to detach something like this from one of those wire loops, and I don't want a blob of water that big around floating in our shower area because I'm counting on being able to suck all this water back, put it in our water bags, and use it for our shower hygiene. The small forces associated with squirting that water on it shoved the sphere down to the bottom side of the wire loop. It was a secant cord on the top side. And now I'm squirting from the bottom to kind of push it back to where it was. Sometimes we get air in with our water supply. And so this one drink bag had a bunch of air in it, so it squirted all the air inside when I was making the sphere. So now we got to figure out how to get the air out. So here's a syringe with a cannula, and you can just suck those little air bubbles out. I didn't think it was going to be such an involved process to make a big sphere of water. And then I held up a little ruler so we can get a length scale there, and it's about 90 millimeters in diameter now. And there you can see that the sphere makes sort of an aberrated lens when you hold the ruler up behind it.
And this one, as you see it here, it's about the size of your hand. It makes this big ugly finger when you put it the right focal point behind it.
A spherical lens, a complete sphere like this is not known to be the best optic for a magnifying lens.
And here you see the sphere made to final size, and you can see it's about the size of my head.
It's about 135 millimeters in diameter, and I calculated about 1,200 cubic centimeters or 1.2 liters of water in that thing.
And I was actually trying to get my head behind the sphere to see what it might do in terms of a magnifier for my nose, but I was never able to quite do that, which is probably a good thing because I think that would have been kind of scary. Now, here we have that big sphere, and it's been allowed to sit and dampen down, so it's a nice quiescent sphere. And what you're going to see is off to the left, you're going to see an irrigation syringe. Now this is a special kind of a syringe. It has a wide tip. It's got a tip about 8 millimeters in diameter, and it's meant for gushing stuff out real quickly. And what we have in this syringe is 10 milliliters of air that we can puff out of this nozzle in about 1/10 of a second, about 100 milliseconds. And we're going to put this puff of air radially directed towards the center of this sphere from about 2 centimeters away. So let's watch what happens with just a little puff of air on this big sphere. When I saw this, again, it made my jaw drop. I mean, it was just amazing to look at all of these waves and oscillations that that little puff of air incited in this big sphere. And there's surface waves that go around the periphery of the sphere, and those dampen down after a while, and then you're left with inertial body waves going through the center of the sphere. And here we're going to see the same thing again now, played back in slow motion, so you can watch these surface waves as they go around. They look like little tidal waves going around, and then they come together 180 degrees away from where the impact was, and they make this big spurt going out, and then that spurt collapses back again due to surface tension forces and sends a whole series of surface waves back to the original point of impact, where you see another little squirt going out. And you see these waves oscillating back and forth, and they dampen down and leave body spherical oscillating waves in the wake of the surface waves. And again, I just thought this was just amazing when I saw this.
After this experiment was over, I was tempted to either stick some lemonade in the sphere and we could all stick straws in there and drink it, or I could suck it back up with a syringe and put it back in the drink bags. And I decided to suck it back up and put it in the drink bags. And we're actually able to save the whole volume of the sphere. It's in our drink bags. We're using it in our shower hygiene area now for taking a bath.
And here we see it again, one more time in slow motion. It can actually drive droplets off of the sphere, as we saw in this case. And when I watched this, I couldn't help but think of computer models that I've seen where it shows some hapless planet that gets whacked by an asteroid and all the resultant dynamics in that. And even though this system is a lot simpler than a planet and the dynamics of when something gets whacked by an asteroid, I sure couldn't help think about the similarities. There's surface waves that go around the periphery of the sphere, and then you're left with inertial body waves going through the center of the sphere.
And Houston Alpha, that's it for our Saturday morning science.